Hello. Hello, Raj. Vrushali, Jesse. How's everyone today?
Hey, I'll be right there.
Okay. So how are the both of you doing in terms of your projects? Are you doing okay? No roadblocks? I know that Raj messaged me in Slack about the reinforcement learning, and I want to go over that. Um, but also, I want to make sure that you give updates and we know kind of where things stand. So, who wanted to go first?
Am I audible?
Yes.
Yeah, so as I messaged you, me and Ankit had a meeting this week regarding the open source sustainability project. We analyzed the last year's NetLogo models in the repository of orthogonal labs. One thing we noticed is there were the models that have incorporated reinforcement learning already, the pre-existing models. It hasn't been implemented to a very good extent, as in it's just a very basic and trivial implementation of reinforcement learning, and the results produced are not very realistic and don't give any significant insight.
Yeah.
So we were thinking that in this year's project, maybe we can incorporate reinforcement learning, but in a much better and in a much deeper way that will actually help us do some analysis and simulations.
Yeah.
So I was looking, like, I don't have any experience with machine learning and reinforcement learning. So I was going through some blogs, some videos regarding what is it about, what is the basic concept, its applications, and all that. And I was thinking that post our discussion, like after our discussion in today's meeting, I'll see to the extent to which I have to learn about reinforcement learning for using it in the project.
Yeah. Okay. Well, yeah. I mean, that would be great if you could contribute to reinforcement learning. That improving. I mean, anything you can do to improve the models would be great. I know that we only got so far last summer. We had to we had like just this little period of time to work on it, and then get some results. But I think it would be great if we could improve it. So you don't really have a plan forward yet, or you want to do this in the latter half of the project period, or how do you envision that?
I think like in the upcoming week, I'll try exploring reinforcement learning completely and getting familiar with it. And once I get some familiarity with it, then it will give me some clarity to decide whether I should do this now or maybe later.
Okay, yeah. Yeah, I mean there are packages that you can use, and of course we also talked about putting things in Misa or the models at least because we have NetLogo, which is limited in a lot of ways for implementing on the web,
Yeah.
and some of the things you can do in NetLogo. I mean, you can do more in Misa because it's in Python, and once you have it in Python, you can hook up to other toolkits. So there's a lot of like machine learning and RL in Python that exists. So that might be a way forward is to go, to move it to Misa and then work on the toolkits from there because that'll just plug right in.
Yeah, I even joined there is a matrix channel for the Misa project, like the actual Misa contributors. So I joined that. I even posted a question there regarding, like, is there any plugin or library that makes the job easier of incorporating reinforcement learning into the models. They mentioned something about some OpenAI gym, some library.
Oh yeah.
I did Google about it, but like I am not very familiar with that or reinforcement learning, so I'll just explore a bit on that, and then if I have any other questions, then I can get back to them and try to solve the problem.
Yeah, I think that's a good strategy. We had talked a little bit about OpenAI Gym last summer, but it didn't go anywhere. I mean, I don't know if I don't think it was that it was too difficult. It was just that I don't think the Himanshu, I think, didn't have time to do it. We had talked about that because we not only have these models that we're doing in agent-based models, but we also have the other types of agents that we use in the lab, like the Brainberg vehicle models and things like that. And we had discussed last summer how those sorts of things can be you can utilize OpenAI Gym as well. So if we had OpenAI Gym up and running, and we could do some things with RL, some training of these kind of models, like our agent-based models here. We could also use it for the Bradenburg vehicles, and as long as we know we have like a good handle on how to use it, and being able to implement something in it that would actually be a broad use to the lab. So that would be great. I don't know how hard it is to implement it or to get it up and running. I can't remember exactly what the problem was last year or why it was not pursued, but yeah.
I'll explore its feasibility in this upcoming week and let you know what I feel.
Okay, yeah. I might also put you in touch with Himanshu. So Himanshu is working on another project in the lab. Like he's working on a Devo worm project for Google Summer Code this year. So he worked on the RL models last year. So I'm not really sure what the deep experience was there, because he did a lot of things and like just made certain decisions. So I might ask him if you want to get in touch with you or you want to get in touch with him. He's in the orthogonal lab Slack, but I'll see if I can put the two of you in touch.
Yeah, sure, that would be very helpful.
So yeah, that's great. Any other updates?
No, that's it from me.
Okay. Thank you. Yeah, it'd be great. It's great to hear. Vrushali, how are you?
Hi.
Hi.
Actually, last week I was working on Blender assets making, but when I exported it in Unity, it's in FPX form. It came out all black because texture was all white out, and then I have to again texture it in Unity. So that's what I did last year. Plus, I am working right now at Morris Waterman's experiment for virtual reality visualizations. So I'm writing the script and other stuff, and also for anatomy.
Okay.
That's it.
So you're working on it, you just don't quite have it yet.
Sorry?
You're working on it, but you just don't quite have a finished product yet, or something you can show.
Actually, let me share my screen.
Okay. Yep, there we go.
Okay, this is actually I also look at the EXA toolkit for controllers. Like these are little controllers, but yeah, I will look at it. Plus for anatomy stuff, I'm just trying to do the texturing and other material import.
We're not seeing your screen. It's black with a logo. Are you sharing the right tab or?
No, I actually like. So, now it will be visible. Now?
It's still not. It's still black.
I could actually see it that time. It was working.
It's okay.
Yeah.
Now?
Yeah, I can see it. I can see it now. Yeah, I see the.
Yeah, even I can see it.
Huh. I can't seem to
Maybe
see it. I don't know why. But
maybe for you, Bradley, could you how on the job bottom there's like the gallery view, like the toggle view?
yeah,
Are you
yeah.
Vrushali?
Yeah, I don't see. I see her icon, and then I see a black screen.
Okay, well she is sharing her screen in another one though, so it was.
Okay. Yeah, I don't know. I can't seem to find it, but that's okay. Are
Mm,
you sharing the
mm,
tab, or are you sharing the whole screen, or
entire screen. I'm sharing
Yeah,
my entire screen.
try your
I
tab? Yeah.
no, it's fine. Like I like there should be there should be a tab in just the or a view that says Vrushali's screen being shared, and on that screen there is the thing. So no, Vrushali, you're changing your stuff too much. Don't change it because I think every time you change it,
Okay.
Bradley's
Okay.
looking for it and it's not there. So just keep yours fine. Because I can see it.
Okay. Yeah, that's okay. Just what? So yeah, it's
Um,
fine.
Now it's visible for you.
It's fine.
Okay. So this is actually I have to texture it again individually or other stuff, and this will be floating. Like I right now don't have that SGRP higher. I don't remember the full form. This will be floating like full kind of thing. So today or tomorrow I will do that. Plus for anatomy stuff, I'm also texturing this again. Like I have the blender file. I told you earlier, but now I have to do it again for individual stuff. Like this is the file. I had this was open source. I think I told you last week. Um, that's the update I have, and I also checked the Blender um Blender uh, um open worm C elegance files. So I will also add that via visualization thing this
could you
week.
could you show one more time the maze itself, just so I want to basically take a picture of it so I can show Bradley if he
Okay,
can.
okay.
Yeah.
Or I don't know if it'll be recorded, but it I'll put
Yeah,
it.
no,
I put the screenshot of the skeleton in the Notion, so if we
Okay.
could just see the
okay, okay.
All right.
I'll show the maze again because it looks good. Or it's like a 3D.
Yeah.
So there we go. I don't know if you can see it in the Notion
So
space.
this is in the Notion doc. Yeah.
I just put it in there. So that's
All
cool.
right.
Okay. If you wanna click this also.
Yes, I have that one.
Okay.
All right. Yeah, that's great. So yeah, so your plans for the coming week are to keep working on this.
My plans for upcoming week is design UI for visualization, texturing and adding materials, plus hand dragging with Unity XR interaction toolkit. That's the thing I will be working this week.
All right. Yeah, it sounds good. Yeah, and so everything's going well. You're not having any major problems, or
So far, I don't have any problem because whenever I have problem, I refer to YouTube or our community, XR community we have in IIT and also the open source community. I know people like XR people who are expert in their field. So I reach out these people. These are literally so helpful to me. So that's it. I don't have right now, but whenever I have, I will let you know.
okay, that sounds good. Yeah, I'm glad that you're finding some support where like usually this is a key part of the summer where you have you know like, well, Raj is seeing this too, where you have a problem and you have to reach out to the larger community of users, and they can sometimes guide you on specific technical
Yeah.
issues. And yeah,
Actually, I was also thinking about extending my GSoC period. Can I do that?
yeah, we can request it. So how long were you thinking?
4 weeks maybe. These 4 weeks is I was only learning. Like I did not do much of things, but if I get 4 more weeks, so I can do it nicely. Like not haste, hastily do lots of things.
Okay. Yeah, I'll see what I can do about that. I have to contact INCF. So yeah, I'll see what they say.
Yeah, I also wanted to actually request for the same thing because probably my July, like major part of the month will be spent in my examinations. I'll still join the meetings and give updates as much as I can, but I'm not sure how much I will be able to work. So,
All right. Yeah, I'll see.
and also this week and next week probably we'll just go in exploring the reinforcement learning stuff. So yeah, I think I may need some extension and extra time.
Okay, that sounds good. Thank you. Yeah, thank you both of you for your updates. All right. So Jesse, you put in the chat that you wanted to talk about a paper. This plus computational biology paper, was it? Or I guess it was on structuring academic writing or
it's
something.
not really a biology paper. It's just the Conrad's 10 principles.
Oh,
for
right,
writing.
right.
I am actually looking at I think it's actually, let me see if I can find the thing. I'm actually looking also at expert writing recently. I don't know if we ever talked about that, but the guy from Chicago who does, he like expert writing as in like writing or communications from people who are really deep in like theory or like law or bio or whatever. People who have a lot of expertise trying to communicate that. So I kind of remember I was having a conversation about that before this meeting, and some stuff I'm doing with JoPro, but it kind of dovetailed into reminding of this paper. So I kind of was more trying to see if that's something that you want to talk about. I don't know what else you wanted to talk about today, or
well, I'll probably spend about 25 minutes on some things on synthetic data, but I'd like to hear about this. I think this would be useful for people.
Yeah, I'll really briefly go over this and yeah, try to make this streamlined a bit. There we go. So, okay, here's that paper. And here's, I don't know if you can see this now, but this is basically what Vrushali was showing.
Oh yeah, I see it.
Here's this lab area in the water maze, and then she showed some assets like the skeleton and the brain and stuff. So
oh yeah, that's great. Yeah, it's wonderful.
I also put that in the Google thing too. I'm gonna reach out to Ankit too, or and that would be cool. Like I'm actually interested in this too, and I'm curious about. I didn't really get to talk to Brian about that part of things last time. So I think talking to Ankit and also Himanshu, like you mentioned, would be really interesting. So I'm curious about that, and I may try to join or help out with that in some way.
Ankit said he'd be joining shortly now.
Oh, really?
This week. Yeah.
I'll go back. Yeah. So this is kind of where it started. I think this will still work. there's this post on LinkedIn, which is not going to load. That's okay. But there was a. I'm not going to play the video here, but you can kind of see a little bit of this diagram. This kind of summarizes it in some ways, but I guess to kind of frame what I'm going to talk about right now, and this is going to be a bit of a very light introduction that we may talk about more later, but just to kind of conceptually discuss something, which is expert writing, which is sort of what this guy is talking about here, and how it kind of relates to 10 simple rules for structuring papers. 10 Simple Rules for Structuring Papers is a really great paper written by Brent Mensch, and Conrad Cording. Conrad is someone that he's very involved with Neuromatch. I think he's at Pennsylvania.
UPenn, yeah.
What's that?
UPenn. It's Pennsylvania.
And he we kind of reference him now and then in the lab. He's someone, I like some of his work and views and stuff like that. But this is a paper that's really not even about. It's kind of domain agnostic. But here's a really great picture. But basically, it's kind of about structuring academic papers. And I don't know if there's a good figure for the context conclusion, but the main like simple rule to think about as you go through all different parts of the papers are content, context, conclusion. And it's kind of like this way of thinking about. I'm not going to go through all these rules because there's in-depth things here that you can go through to make each part of your paper has some commentary about it. But I think sort of a really great takeaway from it. If there's one thing to talk about right now is like context, content, conclusion. And it's sort of like I was just talking before this meeting about this in terms of expert writing, and but before talking about this expert writing over here briefly, I'll say content, context, conclusion basically means. Let me go up to this other one here too. It basically means structuring, and you can kind of see. It isn't said here, but well, hold on. It might be easier to show this way. If it will. Yeah, here we go. There we go. Sorry. So you can kind of, it might be harder to read, but I think it's okay. You can see how like there's each of the three elements of context, conclusion is in these different parts of the paper, and the abstract itself, the blue part is the context, the content is the black, and the red is the conclusion. In that there's sort of thinking about how you want to frame it, what you want to say, and the point you're trying to make about what you've said. And I'm kind of almost seeing it as like different parts of an episode. You hear about storytelling and communication or science communication, the importance of storytelling. But I think about it, I think it's a nice way to think about it in like an episodic discussion. And when you have this artifact, you have one thing that you're doing. You're kind of framing it in giving it context. You're deploying or explaining some content, and then you're sort of finishing it with a conclusion that the point you're making about that content. And so the expert writing part of this is sort of I forgot his name, but he's basically saying when you're communicating from someone who has a lot of expertise in an area, there's a difference between when you're writing, like when you're talking in the lab, when you're talking with colleagues that you talk to every day, thinking and writing are kind of iterative and closely tied to each other. You can write, you can talk, you can think about it. You can kind of go back and forth. But when you're having a communication to a public, when you're speaking to a public, when you're presenting, when you're making a paper, when you're making an article, you don't have that dialogue, and so the value of that process becomes much more about how is it that what you want to say changes what people think about the world. And there's much more detail about all this, but to kind of just briefly touch upon this for future things, there's a really nice way of kind of seeing that a lot of the goal, like the value in writing and the value you can provide people as an expert of when you're providing information is clearly showing how you want to persuade or change, or going from one state of their view of how things are to another state of view, and why that is a good choice to change their opinion or to move or to improve their view on something. And so I think this meshes very well with the content or content conclusion part of Conrad's paper, in that you kind of have to create this artifact that is, not part of the dialogue, but you have an artifact that someone's reading, and it's basically an episode. You're kind of starting somewhere, you're doing something, and you're giving a conclusion. And the quality of focusing on that transition, going from a starting point to someplace else, affects how well it's received and how well there's something salient being said, how much value you're giving the person who's viewing this artifact or listening to you talk or reading your paper or reading your book or whatever it is. And so I know there's other things, and I think Ankit's here, so we can shift to that. But I wanted to mention this because I feel like this is sort of some effective communication, both in terms of communicating like to different people in the lab. Like when you talk to a supervisor or to Bradley or whatever, and you want to give an update, it's helpful to kind of frame it in the context of, okay, we know we can have ongoing dialogue, but if you want to have an efficient communication, thinking about, okay, I'm going to provide context, I'm going to give a starting point, I'm going to say what's happened, and then I'm going to give a conclusion or where we're going with it ahead. And I know we kind of do that in our meetings. We just had updates right now, but it's a really critical thing to think about when you're communicating inside of a lab or also to the public or writing papers. And we have many different forms of assisting with that and talking about that. But I could say a lot more, but I think this is a good stopping point for now, and I'll defer to Bradley if you want to say anything or steer the conversation elsewhere.
That's great. I think that's a nice overview of academic writing and nice overview of communication more generally.
There's a little bit more in the future that I'm working out with this too. Like I'm kind of just getting with the actual writing part of it.
Yeah.
And then this is a little bit more accessible in terms of stuff we've talked about before and in the paper form. So to be continued. But yeah, let's I don't know if Ankit wanted to say anything about the conversation from there. So yeah.
What I did with what's Rajagopalan, I think that's his name. Okay, so update related to that. So I think we sat together and we kind of like, first I got to like a basic understanding of like what his project was, what his roadmap was towards related to GSoC. So like he told me about how he had already made the like a new website he was making compared to like the older website that would be like a revamp. Then we did get into a lot of the Q learning and RL stuff. So what I found, or the problems that we both faced together, was that the thing is that where we are getting stuck, I think this is where I think Bradley you could like help us out, is that I did find that the platform or like the idea behind building the simulation was quite good in my opinion. Like you had like multiple agents and then you are forming some sort of a simulation. But there were like two like problems. The first problem where we were facing was let's say you're building like an simulation for a community. So we were thinking about how do we like approach it. So one of the approaches I think that we came across was like related to like something based on like issue modeling, like modeling how like issues are being solved, not solved, something related to that.
Yeah.
Then I think there was another approach that we discussed, which was more related, more like a global, like a organization related. So that is something that we discussed. I think Raj could probably chip in and talk a bit about the global approach, the other approach. Besides that, I think the place where we found that we were getting a little bit lost is that we noticed that the RL model, whatever we being used, the Q learning model, I think if you see even in the paper itself, it's the Bellman equation, if I'm not wrong. Like
Yeah.
the paper, I think. So in the Bellman equation, I think it's measuring our average expected maximal reward or something, if I'm not wrong. So what I assumed, or like what I personally like I've seen, is that when you like are running like an RL model, like the reward should kind of like increase exponentially as like the simulation is getting better, model is getting better. But like what I noticed was like weirdly, like in the examples, NetLogo examples, I think which Brian had implemented, I noticed like the average that the reward was like totally flat. So that I do not know like whether is that something that should be happening. Then the second thing was that we were thinking a little bit about like how. So I mentioned about how do I like we track the models and the progress. So this was the first thing. The average reward was the first thing that we thought, but there's this problem related to like the flat graph. The second thing that we did thought of was related to I think in NetLogo you have like ticks, if I'm not wrong. So ticks would be something related to like a timestamp of sorts. So I thought like maybe we could like measure like some percentage of, let's say, like percentage burnout or percentage issues solved given the number of like ticks, for example. So this was the second like idea we had for like tracking. And other than that, what was the idea that we thought of with respect to tracking? Give me a second. Just give me a second. Even I have made my notes. Yeah. So the ticks, the reward, and like depending on like what like level we are doing it, like repository wise or organization wise, it would be some metric such as like average number of like issues that are solved in that given time, like percentage issues, or it could be something like burnout or something. So these were like the things that we came across as of now. But I think that I have more to add, but I think I'll stop right now so that I think Bradley you can like provide more input.
Yeah.
I just wanted to add something. Actually, there was also this concept of promotion in the last year's reinforcement learning models, where there is a confidence parameter that is measured throughout. So, like a repository has issues, right? So there were three categories in issue. I think one was Earthshot, Moonshot, and the third one was Mars Jupiter shot issues.
Right.
And they are named like according to their varying difficulty levels. So it was like if a contributor solves a Earthshot issue, he gets 10 points and 20 and 50 points respectively for the Moonshot and the Jupiter shot, Mars Jupiter shot issues. And as and when he gains confidence, I think it was some value, maybe 100. That if a contributor gains 100, like 100 confidence points, then the contributor is promoted to a maintainer. So there was also that aspect in the last year's models.
Yeah.
So yeah, I just wanted to add that.
Yeah, that's it. So about the flat function, sometimes in agent-based models, if they're not set up a certain, if they're not set up in a way that's the model likes, and I say that very qualitatively, but sometimes it won't run well. So you'll have these flat functions. So that's something you can't really avoid in agent-based models, but I'm not really sure what the current thinking is in terms of minimizing that. It may be that we need to use a little bit different approach to, I mean, I don't know the state of the art of reinforcement learning. So if you can find something that works better than the Bellman equation as an evaluation function, that would be good. I mean, it might be better. It might not be. Um, I don't know how I mean, we only have like a certain amount of time this summer. So if it's something that Raj can implement quickly, or if he can, it's a simple Q learning algorithm. Yeah. So I mean, if we want to change the type of approach that we're using for that, you don't have to use Q learning. You can use other approaches as well. But I don't know what the bet like. There's always like people have opinions about what's better, what works better for certain problems, and that's something that's that can be either very easy to address or very hard to address. So that's what I'm getting
Yeah.
at.
So as of now, I think I told him like it's okay that if we stick with like Q learning, because like
Yeah.
obviously I think he might have less time, and like since like we have already like implemented it in Q learning before, I think it would make like a good reference. That's like at least what I thought. So based on what you're saying, let me know whether what I'm thinking could possibly help or not. If not, then we'll find a different way. I think in the net logo simulation, I think last year's simulation that I think Brian had implemented,
Yeah.
we like this like for the algorithm you had like a set of like learning rate and like decay parameters. Do you think playing around with that could possibly help with like getting like a better like reward graph?
Yeah, I think that like the parameters were kind of just a shot in the dark in a lot of ways. Like we tried it. We talked about what might be things we could measure or simulate, and so we put those in there. And they may not be there may be better ways to sort of characterize things. And so one of the things I'm going to talk about is synthetic data, and I'll talk about that in a little bit. But that's going to be something that can be that like those can be changed around. Parameters can be varied, like what's actually being measured, because the idea ultimately is that you'd have someone coming to use this thing, they'd have like certain data that they would have from their community, or they would maybe generate some sort of synthetic data based on a parameter. Like, you can stick a parameter value in that sort of allows the agent-based model to just generate data for that. It generates a distribution and it runs the simulation. So as long as you kind of have some idea of what, and it's usually on a slider scale. So you have some idea of what your community represents. So like you say, the number of contributions. And I say, well, I want about 100 contributions. And, so they have to be sort of intuitive for people to use, for people to put in a value. If they don't have data, or even if they do, that they can map that to the simulation. And so, I think that's great if we could like play around with the parameters, but you have to keep that in mind that if people are using it, they have to be able to know what to put in. They can't just have you can't have this parameter that's like number of contributions per minute or like I'm just coming up with something, but you have to, so those have to be balanced out. I would definitely think that we should, if we can come up with better parameters to use, perhaps those would be good.
Okay, so like from what I understood is that you're basically saying that it should be like usable, like out of the box. Am I right?
Well, I mean, yeah, I mean, if you're going to interact with it, you have to know what values to put in, right? So you have to know, yeah.
Okay. So from what I understood from what you're saying is like we could like find what are like the optimal parameters, right?
Yeah, I think like something that, like if I like the whole thing about the different levels of difficulty, that's something like Moonshot or Mars Jupiter Shot. That's going to be in the documentation. That can be explained to the user, and they can put in numbers accordingly. But if it's like something that I don't know what number I could put in that would realistically reflect what my community's doing. So if I'm just playing around with the slider and I say, well, this is a cool simulation, it's giving me the answer I want, but I don't know what that means in terms of what my community is going to look like, then that's a problem, because we can't really. The whole point is like they have to be able to make the connection between what's going on in their community and then their simulation. So, where the parameters that they're entering. Like some of the things you suggested are kind of interesting. The percentage of burnout, that would be like an interesting thing. You'd have, you could kind of estimate that in your head. You'd say, well, I know that like there's a high degree of burnout versus a medium degree of burnout, and I can just kind of assume that like whatever values I'm kind of putting into the simulation, if I say this is about a medium level of burnout, maybe 30 or 40%, then you get this, this effect in the simulation. There might be a point where it drops off. So you can kind of translate that to what's going on in your community. If your community has, if you see more and more people burning out, you can do a quick calculation and then make an intervention. And that would be useful to people, because they could then understand that there's like a certain point at which you can't recover your community from people burning out,
Okay, I'll let I think Raj like digest a little bit like about what Bradley said. But related to this, I think this burnout thing actually like me and Raj, when we were going through the code, right, there was a part of the code where we realized like there was this concept of like energy, like which is I think associated with what you're saying, but the energy was remaining like constant. So I just woke up one day and I just like thought about it, like would it be nice to like model like the energy in the form of like a radioactive like decay, for example?
Yeah, I think that's how people usually do like
the energy is like continuously decaying, and at like certain point like everyone sort of like burns out, and then at that point we can sort of like evaluate at like which model is better, and like how many issues are solved before everyone burns out. So that would possibly, I feel like, could like help us get better like quantitative measurements. What do you think about
I think like if you're referring to the free energy principle, they use the concept of energy minimization, or sometimes they'll use like a decay function, which what you're describing, which is just like having a constant rate. Yeah. And so that's easy to do mathematically. It's just, how do you want to model it? You want to say like, there's a rate of decay, or sometimes there's a rate of decay that's, of like involvement or connections. And so you can model that as a constant.
Okay. I think I'll let Raj take over from here.
Okay.
Yeah, I think I'll just think about all this. It's a bit or it's a bit new to me, all these concepts. So I'll just think all of it in.
Okay.
And I'll see what I can do.
Sounds good.
I really like the idea of the radioactive decay though, because that like what you say resonates a lot with the sustainability concept also.
Yeah.
So
can I screen share?
Yeah.
Yeah, give me a second. By the way, do you can you share your Gibsonian information paper?
I thought I had in ResearchGate. I think I sent it. Like it sends a copy.
You sent it?
Yeah.
Yeah. I'll tell you why. Because when I was thinking of radioactive decay, right, I thought about this Gibsonian information equation. That is also somehow like having a decay factor in it. So like, is there a way like we can like use the Gibsonian information as a way to get like our to model like energy? Is it possible?
Oh yeah, that would be definitely possible. I hadn't thought about it, but yeah, that would be great.
Give me a second. Let me just share. Screen sharing is visible, right?
Yes.
Yes, it's visible.
So this is the sort of like equation like I thought about, where you would have like an initial energy and like it would sort of like start get decaying, and at like time t you would have some like certain energy value.
Yeah.
So I just looked at the Gibsonian information and I just thought that
Oh
don't you
yeah.
think both are like sort of like this describing sort of like the same phenomenon, or like
Well, yeah. So this is, and without getting too deeply into it, the idea here is that you have environmental information coming in, and it's according to a Poisson distribution. So Poisson distribution is actually where you have like a rate of like energy or information incoming, and it varies by like, if you think about arrival rates of things, like a car is going down a highway, you get like, you can observe that for like an hour, and you'll see that they're like clusters of cars. Sometimes there are no cars, sometimes there's like one car, and that forms a distribution that has like a it's not normal, it's a exponential distribution of some type. And so it gives you this, you can measure it over time, and you can see like different amounts of information coming in differentially over time. Now, you mentioned decay, which is actually an interesting point, because once you have this incoming information, there's also a decay factor in the information. So that's not represented in the equations in this paper, but there is this aspect of decay of information. Like, if you're observing something over time, you get this accumulation of information, but there's also decay that, allows you to forget things, or, if you're building a pattern from that incoming information, sometimes it decays as well. And so you have this it working against you factor where, you can't accumulate all the information you need to form a pattern. And so if the decay rate is very high and the accumulation rate is, and you can set like a Poisson distribution at different rates of like arrival time. So it's like the accumulation would be happen sooner, then it's hard for you to form a pattern. So this is kind of where this is going. But we could use these equations in modeling the communities and some of the aspects of community involvement. I hadn't thought about it, but that's definitely something that could be done.
so it would be a little bit like this. You would start at a certain like, so with respect to, okay, so from what I understood with respect to GI, Gibsonian information, is that it is sort of doing decay, but the decay is with respect to like a cognitive system or something where you have incoming information, but the incoming information is then like obviously like getting decayed. Like for example, I'm just giving an example.
Yeah.
Correct me if my understanding is right based on this. It's like imagine you have a system and like we are viewing certain information. So you have like signals which are basically like images, but that information is sort of decaying based on like that equation. Am I right?
Well, sort of. Well, the way that those graphs work is that that's a summary of the probability of the information. So there are only a select number of times where you're getting a lot of arrivals or information, and then a long period, a long tail where you get very little. And so that K is like the rank order of the events. And so like if you are, you measure all your events, like you have 1,000 observations, and you say maybe 5% of those at best give you like 0.35 probability of getting information, and the rest of them drop off where you almost get no information. So that means that there's a spatial non-uniformity there. And so that doesn't necessarily relate to decay, but what does relate to decay, of course, is if you model it and say, well, if my rate of acquisition is relatively low or relatively infrequent, ability to get information, if there's a decay rate that's above something trivial, then I can really have problems acquiring information and building patterns. The community analog of this would be like if you have people coming into your community, right? And every time point you have a certain number of people, and you have a lot of people or a few people, and your opportunity to capture them and make them into a contributor is a certain rate, and we can model the Poisson process. And then that Poisson process, so if there's a lambda parameter, which is the lambda, if that's low, then you get maybe infrequently you get a large number of contributors. Most of the time you get none or one or two. And so that means that if your rate of decay or your rate of turnover or burnout or whatever is high, you don't have a community because those people just disappear. And so you have very little opportunity to build something. Maybe every once in a while you can find people to sustain things, but then it drops off and decays and dies. So this is, I'm just putting this together now, but I think that would be a great way to kind of think about it too, is you have this rate of people coming into the community, it's non-uniform, then you have this rate of decay where people burn out or leave, and you have to maintain sort of a low decay with sort of a high lambda, which is the arrival rate or input of contributors.
Okay, that was something even I did not actually think about. Like this arrival and burnout. That I think that's like a great concept for like modeling like burnout using this GI, Gibsonian information. Like what I was I think this one is actually a lot better than what I had thought about. I was simply just thinking about if we can use GI, but for like simple, like let's imagine like we have like energy. Each agent has an energy of, let's say, 1,000 at the starting, right? But over a period of time, like the energy decays. That's what I thought of. So what do you think about that?
That's interesting too. Yeah,
not simplistic like this. So what do you think, like between the two like approaches?
Yeah, well, I think like modeling like individuals and their ability to maybe their attention, where they're paying attention to things, maybe like in the community and outside of the community, or maybe within the community. It's like you want to give them enough options to like be interested, but you don't want to give them too many options. And so that's something, and then their interest decays over time or something like that. There are a lot of ways you can model individuals. Yeah.
Instead of interest, I was thinking about like we already had confidence. Yeah. So we already had this thing called confidence, and what it would do was, I think that was also really lovely. That initially we have people with different confidences, and as like the agents which solve more issues, like the harder issues, their confidence increases, and they sort of like slowly get promoted, like from members to like moderators to admins. So we have confidence, but I thought about like energy instead of interest, because like I think modeling interest would be a lot more complicated. Like instead of like energy, like it would be like sort of like a game, like where you have these different like bots, and you're like trying to like fight against them or something. Each of them has like a health bar, so it would sort of like reflect that. So what do you think about that?
Oh, that would be interesting. Yeah. Yeah, that would be interesting. Yeah, I'll tell you what. Put together maybe like a short document where you just put these notes down and kind of describe what you're thinking. Yeah, like a health bar.
I'm writing it in the Slack channel.
Yeah. And yeah, I mean, there's also this gamification factor too, but that's maybe a second layer of what we're talking about here with respect to simulation. I mean, you can simulation, but also gamify.
Yeah. Okay, so Raj, do you have anything to add? I'll stop sharing my screen in the meantime.
Okay.
Also, thank you for sharing the paper.
Oh, no problem. Yeah.
Yeah, the health bar idea is very interesting. I didn't think of that.
Yeah.
That is a very interesting idea. And yeah, I think today's like having a discussion and what you said, hearing to both of your opinions, it was very good. Today's meeting was like I think probably the most most comprehensive meeting I've had. So it has given me a lot of new ideas to think about. I'll have to like after the meeting I'll probably just watch the recording again just to make notes and make sure I haven't missed anything.
Okay.
So yeah, I'll see how it goes.